Welcome back to my channel. For this video, I will discuss solving logarithmic equations applying the change of base formula, a topic for senior high school general mathematics. Muli, kung bago ka lang sa aking channel, mag-subscribe ka na at i-hit mo na rin ang notification bell para updated ka sa mga susunod ko pang mga videos at para tuloy-tuloy ang iyong pag-aaral. Let's start. Another way of solving logarithmic equations is by the use of change of base formula. Particular if the given value cannot be converted into the given base. Let m, n, and k are real numbers with m is not equal to 1 and also n is not equal to 1. The logarithm of k with base n equals the logarithm of k with base m all over the logarithm of n with base m. Please observe that the logarithm of k with the new base m will become the dividend or the numerator. And the base n will become log of n with the new base m will serve as the divisor or the denominator. And m is any desired base. By using the change of base formula, we can solve logarithmic expressions or equations even without a scientific calculator or table of logarithms. Just memorize the following values. The logarithm of 2 equals 0.3010. The logarithm of 3 equals 0.4771. The logarithm of 5 equals 0.6990. And last but not the least, the logarithm of 7 equals 0.8451. We will use that values to solve for the logarithmic equations using the change of base formula. Now, let us solve the problems using the change of base formula. Number 1, log of 32 with base 8 using base 2. Applying the change of base formula, log of 32 with base 8 equals log of 32 with base 2 all over log of 8 with base 2. Next, change 32 to its exponential form, which is 2 to the 5th, and 8 to 2 cubed. Since we have exponents 5 and 3, we will apply the power rule. We will make 5 as coefficient, so we have 5 log of 2 with base 2, and 3 as coefficient, so we have 3 log of 2 with base 2. Applying identity rule, log of 2 with base 2 equals 1. So we have 5 times 1 and 3 times 1, which is equivalent to 5/3. Therefore, the logarithm now of 32 with base 8 applying the change of base formula equals 5/3. In decimal, it is 1.6667. Number 2, solve using the change of base formula. The logarithm of 25 over 625 with base 125 using base 5. So, log of 25 over 625 with base 125 is equal to log of 25 over 625 with base 5 over log of 125 with base 5. Since the value in the numerator is a fraction, it signifies division, so we will apply the quotient rule. So we have log of 25 with base 5 minus log of 625 with base 5. Then copy the denominator, log of 125 with base 5. Next, we will convert all the values to exponent form whose base is 5. So 25 equals 5 squared, 625 equals 5 to the 4th, 125 equals 5 cubed. Then, make the exponents of 5, 2, 4, and 3 as coefficients of its respective logarithmic expressions as stated in power rule. Applying identity rule to log of 5 with base 5, it is equivalent to 1. In other way, it can be cancelled. So we have 2 minus 4 all over 3. 2 minus 4 is negative 2. So we have logarithm of 25 over 625 with base 125 equals negative 2/3. In decimal, negative 0.6667. Number 3, solve log of 75 with base 12 using base 10. Applying change of base formula, log of 75 with base 12 equals log of 75 over log of 12. Base 10 is not written according to the rule, it is imaginary. Simplify 75 equals 25 times 3. Simplify 25 equals 5 squared. Simplify 12 equals 4 times 3. Simplify 4 equals 2 squared. Apply product rule to the numerator. We have log of 5 squared plus log of 3. Apply also product rule to the denominator. We have log of 2 squared plus log of 3. Since we have exponent, apply power rule to the exponent. So the exponent 2 will become coefficients of its respective logarithmic expression. Next, substituting the value, log of 5 is equal to 0.6990, log 3 equals 0.4771, all over log 2 equals 0.3010, and log 3 equals 0.4771. 2 times 0.6990 equals 1.3980. 2 times 0.3010 equals 0.6020. Add the numerator, 1.3980 plus 0.4771 equals 1.8751. Add also the denominator, 0.6020 plus 0.4771 equals 1.0791. Next, divide 1.8751 by 1.0791. The quotient is 1.7377. Therefore, the logarithm of 75 with base 12 equals 1.7377. Again, we can solve any logarithmic expressions by change of base formula using base 10 by simply memorizing the values flashing on the screen. Number 4, find the logarithm of 48 with base 30 using base 10. Log of 48 with base 30 equals log of 48 over log of 30. Simplify 48 equals 2 to the 4 times 3. Simplify 30, it is equal to 2 times 3 times 5. Applying product rule to the numerator, it is log of 2 to the 4 plus log of 3. Applying product rule to the denominator, we have log 2 plus log 3 plus log 5. Apply power rule to exponent 4, it will become coefficient of log 2. Then, copy the denominator. Next, substitute 0.3010 as the value of the logarithm of 2. Substitute also 0.4771 for the logarithm of 3 and 0.6990 for the logarithm of 5. Multiply 4 times 0.3010 equals 1.2040. Add the denominator, it is equal to 1.4771. Add also the numerator, it is equal to 1.6811. Next, divide 1.6811 by 1.4771. Its quotient is equivalent to 1.1381. Therefore, the logarithm now of 48 with a base of 30 is equal to 1.1381. Kung nakatulong at nagustuhan po ninyo ang aking video, please like. At kung gusto rin po natin makatulong sa iba, i-share na rin po ang aking video.